This is Reality Math. Thank you for staying tuned. So we are coming to continue with our calculus. We are coming to take integration today. As earlier we started with integration. Today we are coming to look at the techniques of integration. Whereas we are going to look at partial fraction. We are going to look at substitution. We are also going to look at so today the major focus is substitution. Okay, however, there are also different approaches for integration. Following the questions here, we are going to use integration by substitution. However, what is the concept of the substitution? The substitution is actually to make the complex or how complex the form or a function look to look easier or simpler or to a known one. That is the concept behind the substitution. Okay, so let's first take the first one and see how it have to go. Taking the first one, we are to integrate 2x into bracket x squared plus 1 all to the power 5 dx. Okay, so this is what we are to integrate. So let me put my question here. Alright, so the substitution tells us that let's look at the function. Okay, which part can we represent with a certain variable that after integrating it we can resubstitute it back? It makes it for us to see it no more to be complex, or it makes it for us to see it as something we already know. Alright, so let's see. Let's make u to be equal to this. Okay, so we are making our u to be equal to x squared plus 1. X squared plus 1. But notice we have the x here, so we have to get our dx. By that, let's differentiate this. So we are having the u on the x giving us what? 2x. Okay, so now let's rearrange so that we can get our dx. Then we are going to have the x is equal to what? This is going to give us the u on what? 2x. Let me write my d. u. Alright, so that is my dx. And then now I have my u. Now let's rewrite the whole question and see what we are going to get. The integral of 2x into bracket u to the power 5. Now my dx is what? The u on 2x. Okay, so this is, are you saying it has now become something simpler or something that we all know? A guy that is common to us. You see it? So here we can cancel this guy, take this guy off. Have you seen it? Now when you take that one off, you realize that the whole thing now tends to be u to the power 5 u. And we are so common to this guy, right? If you want to integrate this, what are we going to get? We are going to get the integral. Okay, sorry, this is integration, so this is going to be u to the power 5 plus 1 all over 5 plus 1 plus some constant c. Okay, so we've now gotten this. Let's simplify it out and see what we are getting. So this is giving us what? U to the power 6 all over 6, which is the same as 1 over 6 times. Now my u is x squared plus 1. So remember we'd have to resubstitute it back, which is what? X squared plus 1. Alright. You can leave it, or let me just write it nicely. And then to the power what? 6. So this now become your final answer plus some constant c. Alright, so that is the concept behind the substitution. Let's look at the second one. Okay, for the second one we have the integral of x, the root of x squared plus 5 dx. Okay, now this, it shouldn't confuse you. Even though you have the root here and under the root you are having x squared plus 5, there's an easy way to just integrate this. That's what we are calling the integration by substitution. Now let's make the x squared plus 5 our u, right? So let u be equal to x squared plus 5. Now this guy here is the x, so always let's try to get it out. Okay, so this is going to be what? The u on what? The x. In our previous video you have not watched, I'll drop the link behind. I'll drop the link below for you to see how we integrate and why we have this as the u on the x, because this is in terms of x and this is u. The function is u, so what? The u on the x, okay? And this is what? 2x. All right. So let's rearrange to now get our dx. So my dx will now be what? It will now give me what? The u on 2x. As easy as that. All right. Now you've now gotten your dx. So now let's resubstitute everything back to the question so that we can see how simple the question looks. So the integral of x now into bracket, root u, right? Because x squared plus 5 is u. You see it? The x, and then my dx is what? Du on what? 2x. As simple as that. Now, this that we have gotten, we realize that this is x, and this is also x, so this can take away this. So, we can now have what? 1 over 2, which is what? Half. So, integral of what? The root of u du. So, this is what we are now getting for our question. So here we know that the root of any number a is the same as a to the power half. So if the root of a is the same as a to the power half, we can now change this to what? We can rewrite this to what? Half integral of u to the power half. So now let's integrate this and see. So this is half into bracket u to the power half, okay? This is u to the power half plus 1, right? All over half plus 1 plus some constant c. Okay, so what will this give us? Let's come here. This will give us what? 3 on 2. So if this gives me 3 on 2, let's do some simple calculation here. We are having half times what? Half divided by 3 on 2. If that is divided, you know, we can change it to times and then find the reciprocal of this, which is now 2 on 3. So you know, this take away this, and we are finally having what? 1 on 3. So we can bring it out having 1 on 3, multiplying u to the power half plus 1 plus some constant c. Okay, if you are having this, we know the laws of indices. This is the same as u to the power half times u, right? The laws of indices plus some constant c. Okay, so if that be the case, then let's rewrite what we are having. We are now having 1 on 3. This is u, right? Dot u to the power half. All right. Okay, so plus some constant c. This is just the same as 1 over 3 is multiplying u. The same time is multiplying u to the power half. And we know that u to the power half is the same as what? The root sign here. So we know that the question has been given to us in the root form. So we have to rearrange it to get back what? Our root. So let's see. Let me clean here because we're making use of our u. Let me clean here and then put it here. So we are having what? We are having 1 on 3 u times another what? U to the power half plus some constancy. But we know that our u is x squared plus 5, right? So since our u is x squared plus 5, let's substitute it inside. Okay. So we are having what? 1 on 3 into bracket x squared plus 5, that is our first u, right? Times the root of x squared plus 5 plus some constant c. That's all. You are done integrating this. You see? So that's how easy it is, even though it looks complex. So now we've catered for question 1 and question 2. We can now go to our third question. Question 3. That is our question 3 saying have the integral of x squared, right? 5x cubed minus 2 all to the power 9 dx. Okay, so if you have this, okay, we can see something that is here, in fact telling us that we can substitute it with u. So let's consider this to be our u. So let u be equal to 5x cubed minus 2. Now let's differentiate this. My du on the x is giving what? 15x squared, right? So let's rearrange this to now get our dx, which is giving us what? The x is equal to du over 15x squared. Okay, that's very good looking. Let's see. Now let's rewrite our question. We are now having the integral of x squared into bracket u to the power 9, right? And then our dx is what? Du on 15x squared. But if you look at this critically, you can realize that x squared can take away x squared, making it more simpler. Now this is now coming to look as integral of u to the power what? 9 du all of 15. So let's factor out 1 over 15 outside the integral sign. So we're having 1 over 15 integral of u to the power 9 du. So this guy is common to us. We can now integrate this. Integrating this, we are going to have 1 over 15, right, outside the bracket, u to the power 9 plus 1 all over 9 plus 1 plus a constant c. So that, what are we going to get? We know that this is 1 over 15, right? So 1 over 15 divided by, this is 10, divided by 10, right? So we can change it as, find the reciprocal of this times 1 over 10, which is now giving us 1 over 150. So we have now catered for the denominator already. So let's see, if we have catered for the denominator, what are we going to get? We are going to get 1 over 150 into bracket u to the power 10 plus some constant c. But we know that our u is 5x cubed minus 2. If it's 5x cubed minus 2, let's substitute it back here. We are having 1 over 150. Let me write my 50 well. And this is our u, which is what? 5x cubed minus 2, right? Plus some constant c. So now this now becomes the integral of this. Okay. Now you can pause the video and try question 3. Sorry, question 4. Okay. Okay, so this is trig integration. Okay. So let's see, question 4 is saying, well, cos cube x sine x. Alright. Now from this, what can we let to be our u? And what is the concept? Why should we let maybe this to be our u, or why should we let this to be our u? Now, for it to still make it simpler, that is the idea or the concept for us choosing a term here to be u. Because of that, we'd have to choose a one that when we differentiate to get our dx, we'd have to make sure that that one will cancel either this or this. Okay. So if I put here dx, okay, if I put here dx, and then assuming I take the sine x, I differentiate it, okay. If I can be able to get my dx such that this cos x can be cancelled, or if I pick this as my u, such that if I rearrange get my dx, this sine x can be cancelled, then we are making it more simpler. As a whole, that is the idea behind the substitution method. So let's see. Now here, let me pick cos x to be my u, okay? So let u be equal to what? Cos x. If my u is cos x, when you differentiate u with which is what? Cos x, what do you get? You get minus sine x, okay? So my du dx is what? Minus sine x. Okay, so in our previous video, we'll be looking at trig, how we are going to show the proof of how we integrate cos x to get what? Minus sine x. Okay, so let's see. This is, now let's rearrange it. Okay, my dx will now give me what? It's going to be du on minus sine x. So let's substitute everything back. We are now going to get what? Sorry, I forgot to bring this. Okay. Alright. So this is now going to be, let me write my dx well. So this is now going to be what? The integral of u to the power 4. Alright? U to the power 4 sine x. Now my dx is what? Du over minus sine x. Okay, so this is what I was talking about. You realize that the sine x here can take away this. As far, in fact, it's even making your work more simpler. But mind you, this is minus sine x. Okay, so if it cancels, we know that we are now going to get what? The integral of u to the power 4, right? Sorry, is it u to the power 4? No. So here it is u to the power 3. So u to the power 3, and then u to the power 3. Now this is what is giving us du, but the du is negative, so let's factor out the negative side out. Okay, now this guy we can integrate it, right? It's common to us because so all this, well, that's what we have been integrating. So let's see, if we integrate this, let's factor out the minus 1. If we factor out the minus 1, we are going to get what? And then integrate this is what? U to the power 3 plus 1 all over 3 plus 1 plus some constant c. So what is that going to give us? We are going to get minus, we are going to, let me write it here, right? We are going to get minus u to the power 4 all of 4, right? So we are getting minus here plus our constant c. But mind you, we are having our u to be what? Cos x. So let me replace this with cos x, giving me what? Minus cos to the power 4x, alright? All over 4, right? So this is over 4 plus our constant c. Period. That is that. So stay tuned. Don't forget to subscribe, like, and share. Thank you. This is Reality Man.